In the last video, we talked about how to fill in this axis with our mean and standard deviations. In this video, we're going to talk about some special properties that normally distributed data has. So whenever your histogram makes a shape or whenever data is normally distributed, it has some special properties. So the first property, like we talked about in the last video, this right here represents our mean. And then this is one standard deviation away or above the mean. And over here we have one standard deviation below the mean. And when data is normally distributed, 34% of your data points are going to be one standard deviation above the mean, and then 34% will be one standard deviation below. And then if we keep going with that, if we are in this section, that represents 13.5% of the data. So a data point that is between 1 and 2 standard deviations away from the mean or above the mean, that is 13.5% of the data. And then anything that is more than 2 standard deviations away from the mean, that is 2.5% of our data. And then the same thing is true on this other side. We have the 2.5% and then 13.5%. So whenever data is normally distributed, these percentages are always true. Okay? So there's lots of different ways to talk about them, but basically each percentage tells you what percent of the data points fall within that range. So 34% is within one standard deviation above the mean. 2.5% means that the data, 2.5% of the data is more than 2 standard deviations away from the mean. In the next slide, we'll look at an example of what that would be. So again, those percentages are always true. So I'm going to write them in here really quick. We have 34%, 34%, 13.5, and then 2.5, and then 13.5 over here, and 2.5 over here. And I already set up our axis down here. So our average is 50 inches, so that goes in the middle. And then I added 2, which is the standard deviation, to find these numbers, or subtracted to go this way. So basically this is saying that 34% of our numbers from our data set fall between 50 and 52. So there's a few different questions you could answer with this. Let's say, for example, we wanted to answer the question, what percent of the data was greater than 52 inches? So I would look down here and find 52 on my graph, and I can see that 13.5 and 2.5% of the data is above 52. So 13.5 plus 2.5 would give us 16%. Another example we could ask is we could say, how many standard deviations from the mean is a data point of 48 inches? So if I look down here and I find 48, I can see that it is one standard deviation below the mean.